Alright, this is the last section in college algebra. Alright, section 4.5 is exponential and logarithmic equations. Alright, exponential equations, property of logarithms. If x is greater than 0, y is greater than 0, a is greater than 0, and a is not equal to 1, then the following holds. X equals y is equivalent to log base a of x equals log base a of y. So, for example 1, solving exponential equations. So we want to solve 7 to the x power equals 12. Give the solution to the nearest thousand. Now, usually with a problem, we have the x in the exponent position. We try to get our bases to be the same. But with 7 and 12, it's hard to get our bases to be the same, so we need some other way of solving for x. Well, one thing that we can do is to convert this exponential equation into a logarithmic equation. So if I change this into a logarithmic equation, this would be log base 7 of 12 is equal to x. By making that conversion there, log base 7 of 12 is equal to x, we will be able to use the change of base theorem to solve for x. So what we would put into our calculator is just like we did on the previous section. We would say log of 12, remember to close your parentheses, divided by the log of 7, close your parentheses, hit enter, and I get the answer. We need to round this to the nearest thousand. Alright, so I get 1.276, the 9 tells the 6 to go up to a 7. And that's an approximation, so that's why we make this quick with an equal sign. Alright, so x is approximately 1.277 using that change of base theorem on that one. Now, as we look at example 2, we have to use a different method here. So it's solved. It says, for example 2, solving an exponential equation. It wants us to solve 3 to the 2x minus 1 equals 0.4 to the x plus 2. Give the solution to the nearest thousand. For this problem, I would need my own sheet of paper. So, write this problem again and to work it out. So if I have solved 3 to the 2x minus 1 equals 0.4 to the x plus 2. Alright. One thing that we can use in this process here is one of the properties of logarithms that we went over from section 4.3. And that property of logarithm that we will use is the power property of logarithms. When I do problems like this, I like to use the natural log, which is LN on your calculator. I like to use a natural log to solve these problems. So, first thing I do is bring those exponents down to the front because they contain our x's, to take the LN of both sides, which is the natural log. So I'm going to say the LN of 3 to the 2x minus 1 equals the LN of 0.4 to the x plus 2. By taking the natural log of both sides, which is a logarithm, I can apply the property of logarithms, the power property, meaning I can pull that exponent 2x minus 1 and the exponent x plus 2 to the front of that logarithm. So in essence, this is 2x minus 1 times the ln of 3 equals x plus 2 to the ln of 0.4. And remember, that step is the power property for logarithms. And I put it in parentheses because there's more than one term in each one of those exponents. Alright? So if I have 2x minus 1 times the ln of 3 equals x plus 2 times the ln of 0.4, what I'm going to do here is I'm going to use the distributive property. I have to get rid of those parentheses. So 2x times the ln of 3 is 2x. ln of 3 minus 1 times ln of 3 is just the ln of 3. X times the ln of 0.4 is x ln of 0.4 plus 2 times ln of 0.4 is 2 ln of 0.4. Now I have a situation here. I have x's on both sides of the equal sign. I need to keep those x's to one side. So what I'm going to do is what I call a swap. Alright, I will swap these two terms out. But remember, when you bring it across the equal sign, you have to change their sign. So when I swap these out, when that negative ln of 3 goes to the right side of the equal sign, it becomes a positive. And when that x ln of 0.4 goes to the left side of the equal sign, it changes to a negative. So what we have is 2x ln of 3 minus x ln of 0.4 equals, now when that negative ln of 3 moves over, it's a positive ln of 3 plus 2 ln of 0.4. Now, all of my x's are on the left side, all of my x terms are on the left side. Every term that does not have an x in it is on the right side. So now what I can do on the left side is I can factor out an x. So if I factor out an x, that would be x times, alright, 2x ln of 3 divided by x is 2 ln of 3 minus x ln of 0.4 divided by x is just the ln of 0.4 equals the ln of 3 plus 2 ln of 0.4. Now I got x pulled out. Now I can isolate x because I'm going to divide both sides by 2 ln of 3 minus the ln of 0.4. Leaving just x by itself. And now when I get x by itself, I can kind of lean on my calculator. Now the way I would put this into my calculator is I would put in the left parentheses ln of 3. And remember, you got to put a parentheses around the 3 plus 2 ln of 0.4. Parentheses around 0.4. Close your parentheses for the top. Put your divide sign into your denominator. That'll be parentheses 2 ln of 3, parentheses around 3, minus the ln of parentheses 0.4, close parentheses around the 0.4, close parentheses for the denominator, and then you would enter. So let's put this into our calculator. Parentheses, ln of 3, close parentheses around the 3, plus 2 ln of 0.4, close parentheses around 0.4, close the parentheses for the entire numerator, divided by left parentheses 2 ln of 3, close parentheses 3 minus the ln of 0.4, close parentheses around the 0.4, close parentheses for your denominator. And when you hit enter, you're going to round this, remember, to the nearest thousand. And so now I can say that x is approximately negative 0.23, and that 7 tells the 5 to round up to a 6. I'll give you one more good look at the process. Get all that written down. Remember, once you plug that into the calculator, you have to make sure that you round it to the nearest thousand. That's the way we put it into our calculator. All right. Alright, the next part of this says reflect when solving exponential equations. As in example 1, example 2 above, we are able to get the variable out of the exponent by taking what step? Alright, I can either change that exponential to a logarithm, or by using your power property of logarithms. Alright, for example 3. Example 3 is solving base E exponential equation. So we're going to solve each equation, give the solution, of course, to the nearest thousand. Alright, if we have e to the x squared equals 200, okay? With e, we definitely want to use the natural log, which is ln on your calculator. So if I have e to the x squared equals 200, what I would do is I would say, alright, the ln of e to the x squared equals the ln of 200. Now, power property of logarithms comes into play. So now this is x squared ln of e equals the ln of 200. X squared ln of e equals the ln of 200. Now, what you have to understand is that the ln of e, okay, is equal to 1. The ln of e is equal to 1. So in essence, in an equation, if it's equal to 1 times that x squared, it just basically cancels out. So this would be x squared equals the ln of 200. Our next step would be to take the square root of both sides. So we say the square root of x squared equals the square root of the ln of 200. The square root of x squared is x equals, and then the square root of the ln of 200 is our calculator. The second square root. Now we say ln 200. Close our parentheses around 200. Close our parentheses around what goes under that square root. I hit enter. Alright, and remember, when we take the square root, this could be plus or minus. This would be 2.302. So remember, plus or minus 2.302 because we had to take the square root of both sides. Definitely write this on another sheet of paper. Right. So for part B, if I have e to the 2x plus 1 times e to the negative 4x equals 3e. Alright? First thing I need to try to do is to combine my e's using the properties of exponents. So if I have e to the 2x plus 1 times e to the negative 4x, I can make that 1e because they're both base e. And so I can rewrite this left side as e to the 2x plus 1 plus a negative 4x equals 3e. So when you multiply two exponential expressions together and they have the same base, you can add their exponents together, and that is the property of exponents that I've used. Now, we need to combine like terms in that exponential expression there. So this would be e, and 2x and negative 4x would be a negative 2x. Plus 1 equals 3e. Next, I would divide both sides by e. Alright, you know that's understood to be e to the first power. So if I have e to the negative 2x plus 1 divided by e to the first power, what we do when you're dividing and they have the same base is to subtract the denominator's exponent. So this would be, now when I write that as 1e, e to the negative 2x plus 1 minus 1 from your denominator equals, and on that right side it's canceled out, leaving just 3. Combine like terms now, this becomes e to the negative 2x because plus 1 minus 1 cancels out, equals 3. So now with e to the negative 2x equals 3, I would take the natural log, which is ln of both sides. So ln of e to the negative 2x equals the ln of 3. Alright. Our property of logarithms, the negative 2x comes to the front, so this would be negative 2x. ln of e equals the ln of 3. Don't forget the ln of e is just 1, so 1 times negative 2x is just negative 2x equals the ln of 3. And then you would divide both sides by negative 2. Alright, put that into your calculator. And make sure you round it to the nearest thousand. Put that into my calculator. Get rounded to